Good morning, students. Be happy, it's math time. So let us continue with the exercise 13.1. It's question number 24. In the question number 24, students, find the limit extends to 1 f of x, where f of x that is equal to x square minus 1, x is less or equal to 1. Here two conditions are given to you, that is x is less than 1 or x is also equal to 1. Here this is minus x square minus 1, where x is greater than 1. So students, here it is clearly indicated that on that function we will apply the left hand limit. Here we will apply the right hand limit. And students, if left hand limit that will come as equal to right hand limit, means this limit extends to 1, f of x exists, otherwise does not exist. So we have to check here. So let us come with the left hand limit. Here is the solution of this question. In the left hand limit extends to 1 negative. Here is the minus sign, f of x. This is equal to limit extends to 1 negative f of x. Now this is x square minus 1. And here I have told you, students, this is limit h tends to 0, and it will come as at the place of x, what you will say, 1 minus h its whole square minus 1. In the last lecture I have told you that how we will put at the place of x whatever 1 minus h. Here h is a very small quantity, and this will be subtracted from 1. Here it will lie in the left hand side. So what you will get, students, from here if you will see that h tends to 0, while we will put here as equal to 0, so what you will get, it will come as 1 plus h square minus 2h minus 1. Now here we are putting this limit, that is h tends to 0. You know this will come as equal to 0, 1 minus 1, it will come as equal to 0. So while, students, we will solve this left hand limit, it will come as equal to 0. Now we will solve the right hand limit here. Right hand limit, this is limit x tends to 1 plus f of x. This is equal to limit x tends to 1 plus, what is the function? That is minus x square minus 1. Right, students, it will come as limit h tends to 0 minus into, this is now 1 plus h its whole square minus 1. And student, it will come as limit h tends to 0 minus into 1 plus h square plus 2h minus 1. And while h will come 0, here it is 0 now. So from here you will get minus 1, that is equal to minus 2, then, students. So here while we are putting the left hand limit that will come as equal to 0, here we are putting the right hand limit that will come as equal to minus 2. So we will say that left hand limit that is not equal to right hand limit. What its meaning then? Its meaning is that limit x tends to 1, f of x does not exist. So this is the solution of this question, student. This is the technique that I have told you. This step is very important. Try to understand this step. This step is very important in this question, students. Let us come with the next question. Here is the question number 25. In the 25th question, we have to check that this limit extends to 0 f of x, where the function is given you as, this is given as x mod upon x, where x is not equal to 0. This is 0 when x is equal to 0. This is our question, students. Here very clearly it is indicated that x is not equal to 0. It means either x is equal to less than 0, either x is greater than 0. For that one we will apply the left hand limit, for that one we will apply the right hand limit. My mean to say students, try to understand, ये बहुत इंपॉर्टेंट है आप बच्चों को समझने के लिए कि x अगर 0 के इक्वल नहीं है मतलब x 0 से लेस है, अगर x 0 से लेस है तो इसी फंक्शन के लिए हम लेफ्ट हैंड लिमिट लगाएंगे। अगर हम कह रहे हैं कि x जो है वो ग्रेटर देन 0 है, इसका मतलब है इसी फंक्शन के लिए हम राइट हैंड लिमिट लगाएंगे। क्लियर? आइए देखें। सो लेफ्ट हैंड लिमिट that is equal to limit x tends to 0 negative. This is left hand limit 0 negative function f of x. This is equal to limit x tends to 0 negative. Our function is x mod upon x. Now students, you have to think here that this is limit. Now I am coming particularly on that point because x mod is given and the condition is this x is less than 0. It means in that case if we will remove this bracket from here, this mod from here, we will get minus x upon x because it is toward the left hand side, so it will cancel out. Here it is minus 1 then students. So what we can say now, this is limit x tends to 0 and the function is now minus 1, so it will remain as it is. So that will come as equal to minus 1. Let us come with the right hand limit. This is limit x tends to 0 plus f of x. That is limit x tends to 0 plus, here it is x upon x. Now because it is toward the right hand side, now it will be positive x, it will cancel out. This is 1. So we can say that limit h tends to 0, that is 1, it will come as equal to 1 then students. Here what we are saying? We are saying that left hand limit that is not equal to right hand limit. So therefore what you can say students, this limit x tends to 0, f of x does not exist. It will not exist, and this is the solution of this question students. Try to understand here, but I am doing with that changing, we have to do this type of the question. If you will see students, your question number 26 and 27 both having the mod, very easily you can solve this question now. Come with question number 28. Let us come students with question number 28. Suppose that f of x that is equal to ax plus bx, x is less than 1, 4 when x is equal to 1, b minus ax when x is greater than 1. And if the limit x tends to 1, f of x that is given as equal to f of 1. Here it is given to you students that the left hand limit and the right hand limit for 1 both are equal to f of 1. What are the possible values of a and b? So here what we can say students, here it is given to you that limit x tends to 1, f of x that is equal to f of 1 means left hand limit that is equal to right hand limit that is given as equal to 1. So that thing we will do in this question means first of all we will find out the left hand limit. This question is very important students because this is different type of the question where we are going to find out the value of a and b. So left hand limit, you see here x is less than 1, we will apply the left hand limit here. So limit x tends to, sometime I am using limit, sometime I am using LT. Both are same students. So don't be confused here. We can write here limit also. Limit x tends to 1 negative. The function is in that case that is a plus bx. Right? Now this will come as limit. Now we are changing into h. H tends to 0. This is a plus b into 0 plus h. And students, while h tends to 0, it will come as equal to 0. So from there, what we can say, here it be having x tends to 1. Here is not 0, here is 1 plus h. So what you will say, while h tends to 0, it will come as equal to 0, and from here we will get a plus b. This value will come then, students. Now come with the right hand limit, that is limit x tends to 1 plus, in case that the function is x is greater than 1, this is b minus ax, or we can say that this limit h tends to 0, that is b minus a into what? 1. Here student, this is a plus h, this is wrong. Here this is a minus h, but the result will remain same. Here we will use a plus h. Be careful. So from there what you will get, this will come as equal to b minus a. This is left hand limit a plus b, this is b minus a, and f of 1, that is already given as equal to 4. So what we are saying now, this is a plus b, that is equal to b plus b minus a, and that is equal to 4 then, students. And if we will solve it, a plus b, that is equal to b minus a, you know, b will cancel out, b will cancel out. This is 2a, that is equal to 0, or a will come as equal to 0. This is the first part, the value of a that will come as equal to 0. Now anyone you can take, that is, you know, a plus b, that is equal to 4. We can put this a as 0 here, 0 plus b, that is equal to 4. So b will come as equal to 4 then, students. Here the value of a that will come as equal to 0, the value of b that will come as equal to 4. Once again, students, I want to tell you here, a plus bx, x for the left hand limit 1 minus h. Here for the right hand limit 1 plus h. Be careful while you apply it, and with that way we can find out the value of a and b.